everybody, this is Tech G back with another video, and in this video I'm going to be explaining to you exactly what virtualization technology is. So let's get into it. All right, so imagine this. You got a single computer sitting in front of you. Nothing special, just your average everyday machine. But then you open up a special piece of software, click a few buttons, and now that one computer is running three different operating systems at the same time. One is Windows, one is Linux, and one is macOS. And they're all working independently, just like they're their own machines. So welcome to the world of virtualization technology. All right, so let's start off by asking the question, what is virtualization? So in plain English, virtualization, this is the process of creating a virtual version of something. It could be an operating system, a server, a storage device, or even a network resource. Instead of needing physical hardware for each of these things, you create virtual machines, which are software-based simulations of physical hardware on top of one real machine. So virtualization is kind of like the matrix for computers. You're creating multiple digital realities inside one physical system. Now, in case you need an analogy to help drive this point home, let's say that you got a house, which is your physical computer. Now, normally, one person lives there, kind of like how one operating system exists on Windows. Now, imagine you decide to rent out the other rooms to roommates. Then suddenly, you've got three other people, and those people could be Windows, Linux, and Mac, and they're all living in the same quote-unquote house. But they have their own rooms, privacy, and resources. That's essentially virtualization in a nutshell. So each roommate is a virtual machine. They share the same physical hardware, but they operate independently. So why is virtualization a big deal? Well, back in the day, if you needed to run two different operating systems, then you needed two completely separate computers. And it was the same with running different applications on different environments. And all of that was expensive, inefficient, and just plain inconvenient. With virtualization, one powerful machine can do the job of several. And that's huge for cost savings because you have fewer machines to buy. It's big for energy savings because it consumes less power. It offers space savings, meaning you're dealing with fewer physical servers. And then there's flexibility because it's easier to test and scale. And that's why data centers, cloud platforms, IT departments, and developers, all of them are obsessed with virtualization. All right, so let's go over the key components of virtualization. So to really understand how this works, you need to know a few basic building blocks. And the first part is the host machine. And this is your physical computer. It's the hardware that provides the resources like the CPU, your memory, your storage to the virtual machines. Then you have what is called the guest machine, and this is the actual virtual machine. And when it comes to the guest machine, your operating system or application environment is running virtually. And then you have what is called a hypervisor. And a hypervisor, this is the software layer that sits between your hardware or your host and the virtual machines or your guests. And it allocates resources and manages all of the virtual machines. And when it comes to hypervisors, you have two types. You have type 1, which is also known as bare metal, and this is installed directly on the hardware. And then you have what is called type 2, or hosted, and this runs on top of regular operating systems. So if you see on your screen right here, you got type 1 and type 2. And basically how this works is really simple. You turn your machine on and your machine boots directly into the hypervisor, and then you can spin up your guest operating systems or your virtual machines. That is called a type 1 hypervisor or bare metal. Type 2 is you turn on your computer, you load up your normal operating system like Windows, Linux, Mac, or whatever you got. Then you load up your hypervisor program like VirtualBox or VMware or whatever it is that you're using. And then you spin up your virtual machines. That is the difference between type 1 and type 2. One, you just boot directly into the hypervisor. The other one, you have to boot directly into your normal operating system, and then you go into the hypervisor. That's the difference. All right, so now that you got the theory, let's look at how virtualization plays out in the real world. So we have what is called server virtualization. So instead of one server for each application, you can run multiple virtual servers on one physical server. And each VM can host different applications like email, file sharing, web hosting, etc. And this is huge for data centers because it cuts costs, reduces hardware needs, and makes it easier to scale. You have what's called desktop virtualization. So with desktop virtualization, your operating system lives on a server and not on your local machine, and you just connect to it remotely. So think of it like remote work on steroids. And this is popular in schools, call centers, and businesses where everyone needs access to the same environment. Then there's application virtualization. So you can run applications in isolated environments without installing them directly on your device. And this prevents compatibility issues and lets you run legacy applications on modern systems. You have storage virtualization. So multiple storage devices, they can be pulled into a single virtual storage unit, and that makes it easier to manage, and this can boost performance and redundancy. And then you have network virtualization. So physical networks, they are turned into software-defined ones where you can segment, route, and secure traffic using virtual switches, routers, and firewalls. All right, so next let's go over the benefits of virtualization. So virtualization has taken over IT for a reason. And here are some of the game-changing benefits. First, there's cost efficiency. So the fewer physical machines you have, that means the less money that is spent on hardware, maintenance, electricity, and space. Then there's scalability and flexibility. So if you need another server, well, you could spin up a new VM in minutes. And if you want to clone a system, well, you can easily do that too. Then it also provides easier backup and disaster recovery. So you can take snapshots and backups of VMs to make it easy to roll back if something goes wrong. It offers better testing and development. So you can run multiple test environments on one device. And if you mess up something, you can just reset the virtual machine. And then it offers enhanced security and isolation because each VM can be sandboxed. So if one is compromised, the others will stay safe. Now, understand that not all technology is perfect. So while virtualization is powerful, it does have its share of limitations. And the first limitation is performance overhead. So VMs, they can never be quite as fast as the native hardware. So there's always going to be a slight performance hit due to the hypervisor layer. Also, another challenge is the single point of failure aspect. So if your host machine crashes, then all the VMs on it go down too, unless you've got redundancy that's built in. Then there's licensing and compliance. So some software vendors, they don't play nicely with virtualized environments. So licensing can get tricky. And then there's security risks. So if your hypervisor is compromised, then an attacker could potentially access all your VMs. And that's why regular patching, access control, and monitoring are crucial in virtualized environments. All right, so let's talk about the cloud and virtualization. So if you've ever used services like Amazon Web Services, Microsoft Azure, or Google Cloud Platform, then congratulations, you've used virtualization. So cloud computing, this runs on massive virtualized infrastructures. And each instance that you spin up in AWS or Azure, this is just a virtual machine on one of their many servers. And virtualization is essentially what made cloud computing possible. So if you want a Linux server in Australia, then no problem. Just click a few buttons and the virtual machine is provisioned in the data center on the other side of the world. That is the power of virtualized scalable computing. All right, so let's talk about containers, and are they the same thing as virtualization? So containers like Docker, they are often confused with virtual machines. Now, they are related, but they are not the same. When it comes to virtual machines, basically you can emulate an entire operating system. It runs heavier and it has a bigger resource overhead, but it's also great for running different operating systems. When it comes to containers, well, you share the host operating system kernel. It runs lightweight, fast, and is portable, and it's great for packaging and running applications. So you can think of containers as apartments in the same building and VMs as separate houses on different lots. It's the same idea, but a different execution. And yes, you can even run containers inside of virtual machines. All right, so if you want to play around with virtualization on your own computer, well, here's how you can go about getting started. First thing you want to do, you want to install a hypervisor. You can download a program called VirtualBox, and it's free and it's easy to use. As a matter of fact, this is a screenshot of VirtualBox on your screen right here. Or you can try another option called VM Workstation Player. Then after you do that, you want to go ahead and get a virtual machine image. You want to download a Linux ISO like Ubuntu, Kali, or some other one like Fedora, or you can grab a pre-built VM image and you can find a whole bunch of those online. Then after you do all of that, you want to go ahead and create your virtual machine. And when you do that, you want to assign the RAM, the CPU cores, the storage spaces. You want to mount the ISO file, and then you want to boot it up and install the operating system like you would on a real machine. Now, once you do all of that, then you'll be running a virtual operating system on your host computer. And if you want another one where you could just simply clone it, or if you want to mess around with some malware, but you don't want to mess up your main computer, you can do it in a sandbox VM. If you want to learn Linux, then you could just fire up a distro or a distribution. The possibilities are endless. Now, if you're like, well, how do I do all of this? I need some visuals. There's like 1,000 million videos on YouTube that can show you how to do this in a matter of minutes. It's really not complicated. It's just a matter of you just setting up the VM to your specific requirements and firing up the machine. That's all it really is. All right, so let's move on and talk about careers that rely on virtualization. So if you're thinking about a tech career, then virtualization is a skill that can open up doors. And guess what? It's in demand everywhere. So you'll be utilizing virtualization skills in IT support and system admin roles because they use virtualization for deploying desktop environments and testing machines. Network engineers use it. They virtualize firewalls, switches, and network labs for simulation and testing. Cloud engineers use it. They deploy and manage VMs and cloud platforms like AWS and Azure. Cybersecurity professionals use it. They use VMs for malware analysis, sandboxing, and secure environments. And DevOps and developers, they use it. They use VMs and containers to test applications in different environments. So yeah, learning virtualization isn't just helpful, it's pretty much essential. All right, so let me go ahead and wrap all this up. Virtualization. This is one of those technologies that quietly revolutionized everything: how we compute, how we test, how we deploy, and how we scale. And the best part, you don't need a data center or a fancy IT job to start exploring it. You can do it today on your laptop for free. So if you ever dreamed of running Linux, Windows, and Mac side by side, or if you ever wanted to build a home lab, break some stuff and fix it again, or if you've been curious about the cloud, cybersecurity, or DevOps, then virtualization is your entry point. It is your launch pad because you can have one machine with infinite possibilities thanks to virtualization.